So we're looking at this one here. We've got the 2.2 kilogram block slides into the block with the spring attached. All right. What type, if we're thinking momentum, what type of collision is this going to be? Elastic, because that's we're assuming with that spring it's going to be elastic or pretty close to elastic. Well, the base-Hooke's law, so I would say yeah. Well, we don't. I would wait to answer that, because what are we going to find if it is elastic? What are we going to find? The kinetic energy being conserved. So if we find that the kinetic energy before the collision equals the kinetic energy after the collision, then it's going to be conserved. Yes? No? All right. And so we're looking at what is the maximum compression of this spring. Will be the final velocity of the blocks after the collision, assume that the initial direction is positive. So B is really our idea of conservation of momentum, right? Yes? That momentum has to be conserved in this. And then if it is elastic, we're going to find that the kinetic energies are conserved. So that's, you could actually do that on C. I think you only have one chance on C though.
Yeah.
So what do you guys think? Is it elastic or is it not elastic?
Well, I know the kinetic energy for 83.2.
Okay.
I don't know the kinetic energy after. I don't know the final velocity.
Okay.
Yeah, that's what I feel like consistently having problems with. They only give you like one velocity. They're like, I don't know how to find the kinetic velocity.
Okay. So let's say yes. See if I get it right or not.
Okay.
All right. So a lot of times, Maddie, if they don't tell you about afterwards, they're going to either tell you that it's elastic or inelastic, or they'll give you some other clue. Because you're right, without any insight, you can't do it. So the fact that it's elastic, we know the kinetic energy is conserved. That's going to give us another set of equations that have mass and velocity in them. So we'll end up with two unknown velocities, but two equations.
Okay.
All right. The maximum compression of the spring, we need to look, I'm going to use energy to do that. All right, because I'm going to look at the kinetic energy that the mass 1 has, and this being elastic, and given that mass 2 is greater than mass 1, I need to blow this up to make it larger. You guys want me to cast this out also to the side screens? Okay. I'll cast it out as a window. Given that mass 1 is greater than mass 2, mass 1 is going to stop and turn around, right? Yeah, given that, I say the reverse, given that mass 2 is greater than mass 1, mass 1 is going to end up going backwards.
Okay.
If it was the other way around, mass 1 would continue forward. If they're equal, mass 1 would stop and mass 2 would take off.
Okay.
So the greatest compression is going to be when it's absorbed all of the kinetic energy of mass 1 and then it starts to give a kinetic energy back out. So what I'm going to use here for part A, this is what, number 7? For part A, I'm going to use that the kinetic energy of the block, of block 1, is going to equal the stored or the positional energy of the spring. And so 1/2 m1 v1 squared v1 initial squared equals 1/2 kx squared, where x is what I'm interested in.
So you won't have to take into account so it's going from kinetic energy to spring energy and then again to kinetic energy.
Mm-hmm.
Okay. I wasn't sure if the kinetic energy and spring energy were happening at the same time.
It's going to keep absorbing the energy until we reach a maximum absorption, and then it will start releasing it.
Okay.
It's not going to absorb it and release it at the same time. Okay. Then it would just be a static thing moving. Okay. And I'm hoping, I mean, this is Friday afternoon, and we all know how well problems go on Friday afternoons, right?
Yeah, I feel like that.
Right? And let me go grab a calculator. This one's a little faster. I know. So let's see. My M1 is 2.2 times 7 squared divided by 840. I get 0.358 meters. See if I got it or not.
Yeah, mine's wrong too. I tried last word.
Oh. Okay. The other way for us to look at this, therefore, would be to look through the impulse on it that transfers the momentum, rather than looking at the energies. So let's first do B, and then we'll come back to this one. Okay? Because what this is saying is that before it reaches that maximum, that the other block starts moving. Okay, so let's look at the momentum transfer first, and that will tell us the impulse between them, and we can use that to find the maximum force.
So that's what happens as the block starts moving, so not all
Right.
the energy.
Right. If it was hitting it against a solid wall, it would compress this much. But as it starts to compress, it starts to also accelerate the other block, so it doesn't compress as far. So let's look at B, and then we'll come back to A. All right. So we'll get rid of A here. Go on to B, where we have M1 V1 equals M1 V1 final. Sorry, that should be initial. Plus M2 V2 final. And we have 1/2 M1 V1 initial squared equals 1/2 M1 V1 final squared. We don't know V1 final, we don't know V2 final, but we have two equations with both of them being unknowns, right? So we can set one equal to the other. Let's think about what we know. For M1, mine is 2.2 kilograms, right? My V1 is 7 meters per second. This stays as 2.2 kilograms. And my M2 is 3.5 kilograms. Let me just double check those. 2.2, 3.5. Yep. And then, so I can get rid of all those 1/2, right? So I'm going to have 2.2 kilograms times 7 meters per second squared equals 2.2 kilograms M1F, oops, V1 final squared plus 3.5 kilograms V2 final squared. So my best bet is to look for the to put those into my solver, right? On my calculator, and depending upon my version, let's see. Yeah, I'm gonna pause the screen capture while we do this. Make sure that when it says bad guess on your calculator, it means like you guessed a positive when it's going to be a negative. So for, like I use X for my 2.2 masses, that one's going to be negative, so guess a negative number for that. And if the other one's going to be positive, guess a positive number. Make sure your domain, did you get it? You got two numbers? Good. Got one number. Oh, okay. Not necessarily. Sometimes. Jay, what about you? Okay. I'm gonna pause the video again. Which we would, let's do part A, which we would have already had done if I had been thinking. Because when we first attempted it, I assumed the object came to a rest, right? But the object they don't come to a rest. The maximum compression is when they move together. Which, if it was a stationary wall, would be when the block that was moving came to rest. And that would be when they were moving together. So it's when there's no relative motion between them. So when block 1 and block 2 have no relative motion, that's the maximum compression. After that, then they go out their own separate direction. But it's not this. It's not boing, boing. It's boing, boing. Yeah. I know you're excited. It's fun. So when that happens, if we do conservation of momentum, we have M1 V1 equals M1 plus M2 V2. they're moving together, right?
Yep.
Then we do our energy, but our energy is going to be the energy that comes in with, which is kinetic energy of 1, is the kinetic energy of 1 and 2 plus the potential energy of the spring at that compression point. So we have 1/2 m1 v1 squared equals 1/2 m1 plus m2 v2 squared plus 1/2 k x squared. We can use our top equation to find v2, right? Because we have m1, we have v1, we have m2, we have we have all that except for v2, and then it's plugging into the bottom one to find x.
So it's not like we have to solve.
No. Jay, you want to know what we were talking about for number 1? Give you a 30-second recap. It's not when the first one stops, it's when they're moving, there are no relative motion, so they move together. So that happens momentum-wise when the momentum of the first, and they move together. That's that first line. Then at that point, the energy is going to be conserved still. Kinetic energy of 1 equals now the energy they have is their energy together and how much is stored in the spring. That's what we're doing. You guys think you can do that algebra? Solve for that using the first equation. So use equation number 1 to find V2, plug into equation number 2 to find X. And then memorize that fact. You have to get ready. Okay, it's recording.
What's up?
I'm recording now.